OK, one thing I haven't explicitly called out either, but is something we have to deal with, is that sometimes messages aren't an exact multiple of 128, or whatever this block size is. So when we said that the message was 256 bits, everything was great. You took the first half and put it here, and you took the second half and put it here. What if the message is 257 bits? Well, then you'd have 128 bits here, 128 bits here. You'd have one lonely leftover bit here. So one question we have to ask is, does this encryption work if my message length is not a multiple of the block size, which I'm saying here is 128? So for example, this block is full, this block is full. We have one lonely byte here. Well, I can try running this, but now I'm asking to encrypt the single byte. So I have to take that one byte, XOR it with 128 bytes of ciphertext. What does that even mean? How do you encrypt how do you XOR 128 bits of ciphertext with one bit of plain text? The arguments don't match. And then I have to pass that thing into block cipher encryption. But remember, block cipher encryption expects 128 bits, and you're feeding it one bit. That doesn't work. So you can try to pass in things that are not a length of the block size or a multiple of the block size, but this protocol is just not defined. It doesn't know what to do. It's not clear how you would do this XOR or this encryption, so you're stuck. So the fix is to add padding bytes at the end of the message. So add a bunch of dummy bytes until the message is the correct length. So in this case, because you have this one lonely byte, you might add 127 more dummy bytes so that now this block is all filled up. It's 128 bytes. You can XOR it with the ciphertext safely. The result is 128 bytes. You can pass it into the encryption. So when the message isn't an exact multiple of the block size, we need to apply something called padding. And those are dummy bytes. They're not part of the actual message. We are just adding them to get the message to be the correct length. So what dummy bytes should we actually use? What bytes do you fill in as the dummy bytes? You actually have to be really careful here. There are some traps you can fall into. So one idea might be to just put a bunch of zeros at the end. So if you have a 1 here, then start adding zeros all the way until you reach the next multiple of the block size. But now we have a problem. What if your message already ends in a 0? So maybe you have a message that's like, give me $100. So you have 1, 0, 0, and then you pad a bunch of zeros. Well, then when Bob decrypts the message, he has to remove the padding. How does he know where to chop off the zeros? What if he chops off too many zeros and now it says pay $1 instead of pay $100? That's not so good. So if the message ends in zeros and you also pad in zeros, it's not clear where the message ends and the padding begins. So it's ambiguous. We have a problem. You could try padding with the number 1, but you have the same problem. What if the message says pay Bob $211, and then you pad a bunch of 1s? How do you know which ones to remove as part of the padding? What if you remove too many 1s, and instead of saying 211 in the message, now it says 21 or 2? So padding with zeros or 1s or any constant number has a problem of ambiguity. It's a very subtle trap that you can fall into. So to fix it, you have to be a little bit more careful. There are some different schemes that work, and you'll actually get to explore some of these in your homework, but that's something you can try. So one example, and you'll see more of it in your homework, is to pad by the number of bytes you added as padding. That's kind of clever, and it turns out to work unambiguously, although I haven't proven it here. So just know that padding is easier said than done, and there are some traps that you can fall into.